All right, this is going on page 105 when we're done. And today we're going to talk about inscribed angles. We talked about central angles the other day where the vertex is at the center of the circle. So in these here, vertex is not at the center. And we talked about inscribed figures, or the fact that we had a circle inscribed in a triangle the other day. So we'll look at some other things that are inscribed. It doesn't necessarily just mean inside of something, but inscribed meaning drawn. Okay? All right, so our first definition, an inscribed angle is an angle whose vertex is on the circle. Okay, so the vertex is on the circle and whose sides contain chords. Okay, so it can't just be on the circle and like pointing out or anything, but here's my vertex. It is on the circle, and it says, in this particular case, in this picture, the sides are chords, but it says contains because it could look like this, which is something I'm going to encourage you to do on these pictures, which is draw the angle to where it goes outside of the circle. Okay, so this is an inscribed angle also, and in this case, the sides are raised, which means that it just contains the chords, so it would look something like this. And then with this, we have an arc. And that is what is called an intercepted arc. We talked about that the other day too. So an intercepted arc consists of endpoints that lie on sides of an inscribed angle and all the points of the circle between them. So like we said, if I'm going to intercept the football and I put my arms out, I can grab the football, same thing's happening here. You close the angle, you squish the arc. Okay? And that's exactly how you intercept a football, by the way, like an alligator. So this angle, if it's from the center, you okay back there? That angle right there, which we're going to call this point C so that we have something to call it. What kind of angle is that? Angle C. It is angle DCF. It is made by a radius. Those are both right answers. But if the red one is an inscribed angle, the blue one is, what did we talk about the other day? When the vertex is at the center of the circle? It's called a central angle. Good. Okay, so we've got the red one is an inscribed angle. Blue one is a central angle. Okay, so angle C is a central angle. Angle E is an inscribed angle. Okay, so they are two different angles. Those both, in this case, intercept the same arc. However, they do not have the same measure. Okay? And so I know that whatever the measure of this arc is, let's say it's x degrees, then what's the measure of the central angle? X degrees. Okay, so we know that that is the case. That's what we talked about the other day. So I want you to look at this rubber band that I have. If I have a rubber band and I pull it back and I make an angle out of it, you see that? When I pull it back farther, does the angle get bigger or smaller? Smaller. And the farther you pull it back, the smaller the angle gets, right? The closer it is, the bigger it is. Okay, so when I take this, if you think about this as being a rubber band around a little peg right there, and then you're going to pull it back to put it down E now, where these 2 points stay on the same spot, you think E is more or less than C? Less, okay? So it gets smaller. Does that make sense? So think about it as a rubber band, so you know it can't be the same. It has to be smaller because we're pulling it back. And if this angle is the same as this arc, this angle measure right here is half of it. Okay, so it's still a very easy relationship. It's just not as easy as the other one, which was exactly the same. Make sense? Okay. All right, so inscribed angle theorem, that's basically what that says, is the measure of an inscribed angle is half the measure of its intercepted arc. And then there are 3 cases here of different inscribed angles, and they all, if you see, the vertex is on the circle every single time. The sides are chords every single time. This chord right here, BC, is also a what? diameter. So the center is on the angle. Here the center is inside the angle. Here the center is outside the angle. But it doesn't matter. There's still all three inscribed angles, and they all still have half of that intercepted arc, that relationship. So the theorem, the words that go along with this theorem, is the measure of angle B is equal to half the measure of arc AC. Now, with geometry, when you're writing little equations that go with theorems and you have pictures with them, you have to use the letters that go with the pictures you have, but obviously every angle we look at isn't going to be angle B and every arc isn't going to be AC. So to sort of simplify this into a not a really real equation, is just if you think about the angle is half the arc, think about the theorem that way, write things down that way, you'll always plug things in the right spots. Because, again, it's easy, but sometimes we take half of the wrong thing, or I don't know, we do weird stuff. So that, of course, isn't an official thing because an angle can't equal anything. It would be the measure, but just to have the idea of what's going on, that's good enough. Okay, we're good? All right, so let's look at these. Now, again, I encourage you with the circle stuff. Color is great. You've got colored pencils in your box if you want to use them. There's markers there also. The pencils are way more forgiving than the markers if you mess up, but the markers sometimes are easier to see. So it's up to you. If you're not into color, that's fine, but still extend the angles. You need to mark something. If all you do is just stare at the picture, some of these are going to be so crazy, that's not going to get you anywhere except staring at a picture. Okay. So first thing we're going to do is we are looking for the measure of angle RST. Okay. So RST is this angle right here. So I'm going to extend the angle out past the circle itself so that it looks like that. So that when I do that, it is really obvious what the intercepted arc is. It's arc RT right there. Then if you keep repeating to yourself that the relationship here is that the angle is equal to half of the arc, then that means the angle you want is half of 120, which means the measure of angle RST equals what? 60 degrees. You see how easy that is? But it's only easy if you have the right stuff marked and you know what you're looking for. Okay, the work itself should not be crazy hard, but sometimes it's like a puzzle figuring out which pieces you need. And remember, it is very likely that sometimes you will have to find something they didn't ask you for to find something they did ask you for. At that point, if you feel stuck, ignore the question, go label everything you possibly can, and then go back and look at it, and you probably have the answer in front of you. All right, so now let's look at the measure of arc SU. So that means I start at S, I end at U. It's the measure of this arc right here. So once you know what an arc that you're looking for, you follow that back to find an angle. Now, I can follow this back here like this to get to this angle. Is this angle and this arc, do they have the same measure? No, because is this a central angle? No. Is it an inscribed angle? No. So do you know what to do with it? No, you don't. Okay? So that's clearly not the angle that I want. So I'm going to instead, I could follow it back that way, but this one I could keep going, right? And then I could follow this point back to here so that this angle is the one that is actually going to help me because it is an inscribed angle. I do know what to do with an inscribed angle. And it intercepts this arc that I'm looking for. So again, the angle is half the arc. And so angle is half of, nope, I did that wrong. I know the angle this time, right? So the angle is 40. It's equal to half of the arc. So how do I figure out the arc measure? Multiply by 2. So the measure of arc SU is equal to 80 degrees. Any questions? Good? Okay. Mark stuff on the picture, trust me. All right, so I'm going to give you a couple minutes. I want you to work on C, and then once you get C, work on D, and then we'll talk about them together. Okay, so let's see. Joseph Alsis, have you found the measure of arc ADC yet? Just yes or no? Okay. So we'll help walk you through this. Let's first make sure that we mark the arc that we're actually looking for. So we're going to start at A, and then we end at C, right? Where do we have to go to get there? through D. Okay, good. So I go all the way around here through D. So this is the arc that I'm looking for. So remember, once you find the arc that you're looking for, then you've got these endpoints. You've got to find an angle that's related to it. So in this case, I'm going to follow it back to here and here. So my angle, this is the angle that intercepts that arc. So Joseph, do we know that angle measure? Yes. Okay, so tell me the relationship between the angle and the arc. Angle equals, just in general, I don't want numbers or anything. The arc. Okay, good. So then we plug in what we know. Which part of that do we know, Joseph? The angle. We got 135 is equal to half of the arc. And then what do I do next? Good. Multiply both sides by 2. So the measure of arc ADC then is what? Very good. Y'all agree with that? Okay, good. And my guess is he wasn't the only one that hadn't found it yet. And those of you that hadn't found it yet, did you actually have your arc marked like that? Yes, mark the arc, find the angle, and then bam, it is right there in front of your face. But again, if you just stare at it, you're just staring at it. Like, you're not going to get any farther. Okay, so then let's talk about angle DAE. Miguel, did you find this angle already? No. Okay, did you mark the angle? Okay, so here's angle DAE, right? And it intercepts this arc. Looking for this. All right, so what's the relationship between the angle and the arc? Okay, so angle is equal to half of the arc. In this case, it's 76 degrees. So what's half of 76 degrees? 38. So the measure of angle DAE is equal to 38 degrees. Okay. Questions about that? We good? Label, 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 people. Those were just two things on one picture. You might have a whole lot more than that. Okay, so then we have a corollary. Corollary says, and remember, a corollary is just like a theorem that comes directly from another one. Inscribed angles of a circle intercept the same arc, then they are blank. Okay, so let's look at the picture first. And we've got angle ACB, this red angle right here. Angle ACB. It intercepts arc AB, right? Then we have this blue one, ADB, this angle right here, also intercepts this arc. And then this green one, AEB, also intercepts that exact same arc. So each one of those angles are inscribed angles. So they're all half of their intercepted arc, and they all intercept the same arc. So what do you think has to be true about all the angles? They're congruent. Good. So all of the angles are congruent. So my conclusion can be that angle C is congruent to angle D, which is congruent to angle E. Now there's a lot more angles on this picture. I want you to look at angle CAD. See angle CAD? Okay. So see if you can find an angle that would be congruent to that angle. Anybody have any ideas? Danielle, what you got? CBD, y'all agree with that? Yes, CBD would have to be congruent because it also intercepts that arc right there. Okay, does that make sense? Good. And there's a lot of other congruent pairs on there, but I think if you look at like, I don't know, these right here, those intercept the same arcs. There's other ones on there, but we're not going to label every single one of them because it would be like way too much on that picture. So we'll just go with angle CAD is congruent to angle CBD. The more secant lines and chords and stuff you get, the more angles you get, and the crazier the pictures can be. Then at some point when they're small, you got way too many labels on there. Okay. So let's look at this. This is a picture of streak art, okay? I know what string art is. You like literally sew things from point to point. It makes this pretty thing. And they're telling us that the measure of arc AD, this right here, is 86 degrees. And that the measure of angle A right here is 60 degrees. Okay. So I'm going to give you a minute on this one also. Find the measure of angle DEC, and then once you do that, you can move on to B. Okay. Adriana, have you found the measure of angle DEC yet? No? Okay. Have you found, okay, let's mark what we're finding first. So we're looking for the measure of angle DEC. So let me ask all of you this. That angle intercepts arc DC. Is the measure of that angle that we're looking for and that arc, are they the same measure? Like if I knew what this was, if I said DC is 20 degrees, then does that mean this angle is 20 degrees? No, because this is not a central angle. This is also not an inscribed angle, which means it's not an angle that I know how to directly find. Doesn't mean I can't find it, but it's not one of those two rules that we have. Okay, so Adriana, did you find anything at all that was like you were on your way and you were finding some stuff? Did you label anything else besides what I labeled? No? Okay. So tell me, if I can't find it using circle and angle properties, what else might I know that could help me find angle E? Like what other kind of properties might I be able to use, Adriana? Is that angle part of anything else besides a circle? Triangle. You see it's part of a triangle. So maybe I can use the fact that this is a triangle here to help me. Does that make sense? Okay? Because what happens sometimes is we get tunnel vision, right? We're thinking about circles and inscribed angles, and then we lose sight of the fact that we actually know stuff about triangles and some other things. So I'm looking for this angle. I know I can't find it directly, but the other angles in that triangle, if I look at angle C, is angle C an inscribed angle? Something we could find? Okay. All right, so, bam, got that. And there's other ways to go about this. We'll talk about the other ways here in just a second. Okay, so Adriana, tell me, what's the relationship between the angle and the arc? What's my little equation? It's not really a formula. Good. So the angle is equal to half of the arc, which is 86. So the measure of angle C is 43 degrees, which is not my answer because I'm not finished, but it does give me something. Okay. So then let's talk about angle D. Get somebody else to help me with angle D. Here's angle D. So who can help me with angle D? Sebastian. Angle D is 120 degrees. No. It's 60. Why is it 60? He's not questioning everything he's ever known because I asked him why. Okay, tell me why it's 60. Okay, okay, how do you know the arc's 120? Good. Okay, so this angle right here, D, that I'm looking for, intercepts that arc. Then angle ABC also intercepts that arc. So this is 60 degrees, which means this is 120, which means that this is 60 degrees. Would I have to actually get to the 120 part of that? Like, do I have to actually find this number right here? Do I have to actually find the number? No. If inscribed angles of a circle intercept the same arc, bam. Angle A and angle D intercept the same arc, right? So there's nothing wrong with finding 120. That's why that corollary works. But I wouldn't necessarily have to find this number. Like if this was something weird, I wouldn't have to find that, and I know automatically that A is congruent to D, even if I don't know the measures. So I know then that the measure of angle D is equal to 60 degrees. So now can I find the measure of angle E? Yes. because I'm using the fact that there's 180 degrees in a triangle, right? So I'll call that x. So x is equal to 40, no, it's not equal to, x plus 43 plus 60 equals 180. So x plus 103 equals 180, which means x equals what? 77 degrees, and that is the measure of angle DEC. Okay. Now, that's what I was about to ask. So what did you do? Angle what? B. Okay. So find the measure of angle B. Right there, right? Because the measure of angle B is what? Half of 86. So it's 43. And notice that this angle right here also intercepts that arc. So we got the 43. Okay. And then what? This angle. Uh-huh. Okay. Good. Because they're vertical angles. Okay. That work? That totally works. And whatever makes the most sense to you at the time that you're doing it is the best way, because there's not a best way necessarily. Okay. But one of those two ways you kind of have to. Okay. Questions? Either way is fine. All right, good. So then let's look at the measure of angle ABD. Daniela, ABD. What you got for that? 43 degrees. Okay. ABD. And if you do it the way Fernando said, we already had it, right? Either that or once we found this, we know that they're congruent. So the measure of angle ABD is 43 degrees. Good. And then measure of arc BC. Joseph Zuniga, 120, because we had that labeled also. Measure of arc BC. But if we didn't, it would be an easy thing to find. Okay? Questions about any of that? So again, just if you're stuck on what to find, forget about what it's asking you. Go find everything you can. Then come back and you probably have stuff labeled that would be helpful. All right. Next theorem. If a quadrilateral is inscribed in a circle, so let's just pause right there. Remember, inscribed does not just mean that it is inside. For a polygon to be inscribed in a circle, that means that all of the vertices touch the circle. So if it is inscribed in a circle, then its opposite angles are blank. Okay, so we're going to come back and fill that in. Let's look at the picture first. So opposite angles would be A and C, obviously, and then B and D. So if I took angle A and I extend, oh goodness, I'm going to extend it outside the circle, like so. This is my intercepted arc. We all agree with that? So then the angle opposite of A is C. So I'm going to extend that out of the circle. That means this is my intercepted arc. So together, those two opposite angles, A and C, intercept how much of the circle? All of it, okay? Which means then, since A and C are both inscribed angles, that their measures together, the sum of A and C together, has to equal what? Does the inscribed angle equal the arc? No. 180. If it intercepts the entire 360, it's not 360 for those two. It's half of that, and so together A and C have to be 180. Does that make sense? Because the entire circle gets inscribed. The same thing would happen with the other opposite angles. If I drew that on there, they'd just be like way too much. But you can see that basically angle D is going to intercept arc AC this way. B intercepts the AC this way. So again, the entire circle gets intercepted, which means that together, I don't know what they are individually, but together they have to give you 180. That's important for you to stick in your brain because you are going to want to make the opposite angles congruent, and that is not what is happening here. Okay? Is it possible? Yes, but not as often as you expect it to be possible. If I have a quadrilateral and the opposite angles are congruent, that guarantees me it's what quadrilateral? Parallelogram. Okay, so just think about a parallelogram. If I have just a generic old parallelogram, can that be inscribed in a circle? No, because if the vertices have to be on there, that's going to be an ellipse, which you know of as an oval, right? Like it can't be a circle. You with me on that? So, and just a generic old parallelogram cannot be inscribed in a circle. A rectangle and a square can be. So some parallelograms are, but not all of them. So if a rectangle and a square are in there, then their opposite angles are supplementary, and they also happen to be congruent. But the supplementary part is what's happening with circles here. Okay, so don't be thinking congruent, because that's not what's happening. So our rule here then is, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. They are not guaranteed to be congruent. So my conclusion here is that the measure of angle A plus the measure of angle C is equal to 180, and the measure of angle B plus the measure of angle D equals 180. Okay. Any questions? All right. Okay. So let's find the angle measures in inscribed quadrilaterals. And to find the measures of PQRS, this is a quadrilateral. How many total degrees are in a quadrilateral? 360. So can I add all four of these angles up and set them equal to 360? No, because I don't know angle S. If I knew angle S, then I could do it that way, but I don't know angle S, right? So can I set any of these angles equal to each other? No, okay? So I know that opposite angles are what? Supplementary. So which two angles can I use? P and R. I cannot use Q and S because I don't know S, but I can use P and R. Those are my opposite angles. So I can say that 6y plus 1 plus 10y plus 19 equals 180. So that gives me 16y plus 20 equals 180. So 16y equals 160, and y equals 10. So then I need to plug those in. So I get 6 times 10 plus 1, which is 61 degrees. Then y squared plus 48, so 10 squared plus 48 is going to be 148 degrees. 10 times 10 plus 19 is going to be 119. Right. So then to get S, I could add them all up, set them equal to 360, but I know opposite angles are supplementary, so this is just 180 minus 148. And so that would give me what? 32 degrees. Then I got to make sure I answer the question. Measure of angle P is equal to 148. Oh, well, no, I'm sorry, 61. Wrong one. Come on. Measure of angle P is 61. Measure of angle Q is 148. Measure of angle R is 119. Measure of angle S is equal to 32 degrees. Okay. Any questions? All right, so you work on the last one while I hand out this. So I think you've gotten at least this far. Now, talking about working smarter and not harder, when I do 9 times 16 over 2, do I have to actually do 9 times 16 first? No. What is 16 divided by 2? 8. So this is just 9 times 8, which is 72 degrees. And then to figure out J, that's just 180 minus 72, which is going to give me 108. So the measure of angle J is equal to 108. Measure of angle K, oops, I didn't put a J there. Measure of angle K is equal to 129. Measure of angle L is equal to 72. Measure of angle M is equal to 51 degrees. Okay, any questions? Alrighty, then go ahead and glue that in.